So now that EKS cluster we can provision from, say here AWS, say here in our AWS Terraform tutorial. So normally we have done already all these, but if you go to AWS services, in the AWS services we have EKS cluster provisioning. So here we have a provision and EKS cluster. So now here in this we have one GitHub repo. From this GitHub repo we can provision like either from the HCP Terraform or community edition. We are using Terraform for the community edition. Then here they have given one GitHub repo. So in this they have developed using Terraform modules. If you don't want to do this one, even we can do it through the GUI also we can do. But as of now, we are going to manage through like a Terraform. So now here we have main.tf. And if I go to the main.tf, here we are using a provider. Okay, and which are the available zones, all these. And they're using one module VPC. Means it's creating the VPC also. And it's a education hyphen VPC name we have, right? You can give your own name like maybe CloudSoft hyphen VPC or project related. Then here what is the module we are using? What is the module we are using? EKS is the module. And what is the source meaning is from the Terraform registry itself, we are getting that module source and that module version. This is not that EKS version. And EKS cluster version we are provisioning here is EKS cluster version we are provisioning here is 1.29. If you don't want 1.29, you can give 1.3132 like this
2.39.
also. 1.3132 like this we can give. Okay. So then this we have this Terraform AKS cluster we have, right? This module what we have will discuss. So now here we are going to use so that module just we are using here. So now from this GitHub repo we can get that. So now here if we go for the main.tf, so from the main.tf here we are going to use our resources, whatever the resources we want to create now. Here this is creating one EKS cluster. Okay, so then like a VPC, all those details also it is taking networking. Okay, from this module, this is our driver script, and this driver is calling that EKS module, and from that we are going to create the resources. From that we are going to create the resources we are creating. Okay, so then like all these details we are passing, and what is the meaning of node groups are like in order to manage the worker nodes kind of thing, we are creating node groups. And here what is this meaning of minimum size, maximum size, desired size is, what is that meaning of minimum? Say node groups, similar kind of missions we are going to create, like it's a auto scaling kind of thing also. Like if we can create the cluster autoscaler kind of thing. So those related minimum maybe real time we can give maybe 4 or 10, maximum you can give maybe 40 or 100, and desired state maybe 4 or 5. Like this, here we can give that. And here in this itself, they are going to create two node groups also. Depends upon our project. We can create multiple node groups also. Okay, so multiple node groups also we can create. Sorry, we can create. So now here we have created one cluster, and from that we are going to create multiple node groups. We are going to create multiple node groups. We are going to create. Okay, yeah. So now here once we create that cluster, okay. So once we create the cluster, so what we need to do? What we need to do is, see here it is using one CSI driver also, that is like a one of the add-on kind of thing also. All these are getting created. Now, if you go to EK's workshop, so once we created the Terraform, either that's through Terraform or like GUI wise, what I want is EK's the cluster is required, then we can do that like based on the EK's workshop. Okay, so we can do these labs. So now here we can do this introduction, like navigating the labs. So as of now we are not at the AWS event. In our AWS account itself we are going to do the Terraform. Like, and using the Terraform, here also they have given the Terraform steps also. So from this also we can create our like a EKS cluster. Once the Terraform has been created, what we need to do is like navigate the lab. So now here they given the sample application. Okay, so we need to clone this repo. So how we can get that repo is, so now here they have given this GitHub repo. So from this GitHub repo, what we can do is we are going to get all these manifest files and websites, all these we are getting. So maybe if you go to the labs or somewhere, not labs, maybe module something, manifest. So base application, they given the complete project for us. So this application we need to set up. So now here, each one, like here, what are the things we have is assets, cards, catalog, checkout. So these all one microservice. So now here UI is one microservice, other is one, orders is one, checkout is one, catalog is one, cards, assets, and we are going to use RabbitMQ. So these all we need to deploy. And if I go to the catalog microservice, and we have different YAML code also. Say we are going to use the stateful set or deployment, then config map. So these all you need to go through. Then each one how we can set up is like on your Kubernetes cluster. I shared that GitHub repo. Everyone need to clone this GitHub repo, like till this EK's workshop and our application where they have given in the manifest, that base application. In the base application we have like these choose one thing and check out this, and from this we can deploy the kubectl apply -f namespace.yaml. Like this we need to create. If you want to create all as a single shot, you have customize is also one of the option. Okay, so these all we need to set up on your Kubernetes cluster. And in order to deploy these all as a bulk, we have one option, that is customize is one option. If you come to this EK's workshop itself, okay, so now here how the packaging can be done, and they have the Docker file for each microservice. What is the Docker file also? You just go through. That means this is our application already, like EK's workshop has given. Depends upon our requirement. Like we have developed all these like this. We need to project. and this one we need to spin up on your Kubernetes cluster also. We need to spin up. So on our Kubernetes cluster also, we need to spin up this cluster. We need to spin up. Okay, so now here, what we are going to do is, like for each microservice, they have given the Docker file also. Go to this Docker file and how the microservices communicating all this, and our deploying our components we can use using kubectl. Okay, so these all you can do it either from the Visual Studio or from the instance what you have taken, that base application. In that default namespaces we have this, but we can create our own like in the catalog, like we have the deployment, all these manifest using the kubectl apply -f we are going to deploy. If you don't want to deploy like that, you can use customize also we can use. So what is the customize is? The customize is one of the like bulk kind of, either we can use Helm chart. Okay, so we can use the Helm chart or we can use customize also. And if I go for the customize kind of option, there will be one YAML code. So once we write all these manifest files, there will be one customized file. Okay, and with the single command, we can create all these. So suppose here, what are the different resources we have? So if I go to the catalog, I have config-map.yaml, deployment.yaml, customization.yaml, namespace. Multiple manifest files you need to create. Instead of creating them multiple things, what we are going to do is, we are going to deploy all these as a single shot we are going to deploy. For that, we have writing one more YAML file, customization.yaml. In this, what we are specifying is, all these resources in which order you want, you are going to specify. Means I want first namespace, then secret, then config map, then service account, service deployment. All these once you write, what is the command you are giving is customize that folder name. If you give, all that resources are getting created as a single shot. All that resources are getting created as a single shot. Otherwise, what we need to do? Otherwise, what we need to do? We need to create all those manually. We need to create. So instead of creating all of them manually, what we are doing is we are using the customize option, and using the customize option itself, we are going to create all these as a single shot to the like one shot we are creating. If you have the multiple directories also, that means I have multiple microservices. Okay, so in that use case, what I'm doing is, say if I go for my base application, assets is one directory, cards is one directory, catalog, checkout, orders, all these in the single customized YAML code I'm keeping. That means in the RabbitMQ, I may have a lot of resources. All are getting created as a single shot. Catalog also getting created as a single shot. Cards also created as a single shot. All these we can create as a single shot by using the
Customization.
customize. But the small application, we can go for the customize. In the real time, you can tell we are using the Helm charts. Okay, so Helm also we have 3.x version, and using the Helm, we are going to tell we are going to create the resources. So using the Helm, we need to tell we are going to create the resources we are going to create. Okay. So one method is either customize we can use, or you can use the Helm also. And if I come to the Helm lab, here we need to have Helm also need to be installed. Okay, then Helm after we install, mostly if you do it all this from the Cloud Shell in the browser, automatically we are getting all this. Then from the Helm chart itself, we are installing all this. Okay, so through the Helm, all these commands if you run, Nginx, those are through the Helm itself we are going to install. Okay, so these all the commands you need to type. Yeah.
Yes, sir. So these two are different types.
Yes, yes. Either
Customization and
customize
Helm.
will use or Helm will use, but in the real time,
But we
mostly
are
will use
using
Helm
only,
itself.
but we are doing only one process like Helm or
Either Helm or
customization.
customize or kubectl manifest files.
Okay.
Okay, so that each one you can run as a kubectl manifest file. You can run
Mostly in real time, which type we are
Helm.
using?
Helm you
Helm or?
need to tell Helm.
Okay.
Okay, so after this intro is the basic one, then like we need to come to fundamentals. So everything is that in that GitHub repo itself. I shared in the chat. We need to attach EBS. Okay. So then stateful sets, load balancers, ingress. So these all we need to finish. After that, very, very important is observability. What is the meaning of observability? So observability we are using for the logging purpose, like that we are going to use. Means for the monitoring and the logging, we are using observability. For the monitoring and logging, we are using observability. We need to tell. Okay, so this lab we have, right? Observability with OpenSearch or container insights. In this itself, we can tell even Prometheus and Grafana also. Okay, so now here OpenSearch is nothing but Elasticsearch kind of thing, and the container insights, and here we have AMP is nothing but Prometheus, Grafana. So these all like very, very important. In this, just we need to do intro, and in fundamentals we want load balancer, ingress, EBS. Remaining all not required. Okay, then observability. And observability also. Okay, so we need to set up these all pod logging. These all very easy things. Okay, so but what we required is in the open source we required like monitoring using Prometheus, Grafana. So those all we required. In the open source observability, AWS distro with open telemetry, but here this is AMP is there. AMP is Prometheus itself. I said to do it in Docker Compose, but here we can do it on the AMP now, like in available AWS itself is available with Amazon managed Prometheus and Grafana. So this setup, like try to connect to that EKS cluster, and till this at least this intro we have, right? This through customize or through kubectl, try to set up the environment. Okay, so then like maybe we may have a version of 1.29, how to upgrade to the higher version. Those all will discuss in the next sessions. This at least through customize and that Helm commands. Once you spin up your Kubernetes cluster, try to execute. Okay, so that's try to finish as the very, very important thing. Then we'll go for fundamentals and observability we need to finish. Okay, so these lab if you do, so when you set up the EBS kind of thing for the storage, stateful sets, all that manifest files we have, the same application we can tell, but with other names we are going to tell in the real time also. And for each and every microservice, we have the Docker file, everything we need to spin up on our applications. Okay. So these try to finish. Which one you need to finish? This intro step. Say here in the setup anyhow, we are spin up either through Terraform like this. You can spin up. Okay. So after that we need to download this application. These we need to deploy either through kubectl also we can deploy, or through customize, or later we can use Helm charts also for the deployment. Okay. So this like in your AWS account also, using the either through GUI or EKCTL or through Terraform. So now, Kubernetes cluster, how we are provisioning here? How we are provisioning that Kubernetes cluster? Through Terraform itself, we are going to provision that. Okay. So once we connect to that, like we need to do all these things. Maybe in your Visual Studio also, you can clone that GitHub repo which I have shared. Otherwise, in the EKS workshop itself, here we are going to get that GitHub repo also. So from this, we can manage all these things. Okay. So that's try to finish by tomorrow session. Then like once you've done this intro kind of thing, then we'll come to how to do the fundamentals and observability. These all only just to set up the environment itself, this one. Once we done, then we'll come to this part. Okay?
Okay.
Yeah.
Okay, sir.
Sure.